Welcome to Module 2. Module 2 is about transmission media. And if we look into the position of transmission media in a computer network or data communication network, this is the position that is just below the physical layer of a device. We have the transmission media. Suppose the sender and the receiver are directly connected using a cable. In that case, this cable or transmission media comes under the physical layer of the sender and physical layer of the receiver. This is the position. So as you know, in a network, the software, we have a set of layers, right? OSI reference model or TCP/IP reference model. The entire network software is divided into different layers, right? So end devices like computers and all, we have all the layers from application layer to physical layer. So application layer is the uppermost layer and physical layer is the lowermost layer. And in intermediate devices, depending on the type of intermediate devices, lowermost some of the layers will be present in the device. Just for example, in case of a repeater, we have only physical layer, and in case of hubs and all, we have data link layer and physical layer, like that. Okay, so whatever may be the device and whatever may be the model we are using, physical layer is the lowermost layer of a device, and from there we are connecting the transmission media. So this transmission media is actually controlled by the physical layer. And if we try to define this transmission media, it can be broadly defined as anything that can carry information from a source to a destination. Anything that can carry information from a source to a destination. Just for example, if two people are talking each other, air is the medium of communication. Air is the transmission media. Like that. In case of data communication or computer communication, we can classify this transmission media into different categories. Broadly, we have guided media or wired media, and then unguided media or wireless media. And different types of guided media are there. Cables are there, twisted pair cable, coaxial cable and fiber optic cables are the main physical cables we are using for data communication. And under unguided media, we have radio wave for communication, microwave and infrared. And coming to the details of each and every media, guided media first. So in case of guided media, it provides a conduit from one device to another. A physical circuit or physical cable will be present for communication. With this type of physical circuit includes either twisted pair, coaxial cable or fiber optic cable. And a signal traveling along any of this media is actually directed by this media, right? So depending on the shape of the cable, length of the cable or the position of cable, physical organization of the cable, the signal is always passing through this cable. So it definitely is directed by this cable, right? And it is contained by the physical limits of the medium. So whatever may be the medium we are using, whatever limitation it is having, the corresponding signal also will be affected by such limitation. For example, data rate or quality, noise, inclusion, all those things are actually affected for the signal, right? So thus we can say that the signal is contained by the physical limits of the medium. And usually the twisted pair and coaxial cable use metallic, usually copper conductors that accept and transport signal in the form of electric current. So in case of a twisted pair and coaxial cable, signal pass in the form of electric current. So we will first convert the data we have to communicate. That data will be converted into signal. In case of these two cables, this signal is actually electric current, and in case of optical fiber, that is not the case. This accepts and transports signal in the form of light. So in that case, data is converted into signal which is transmitted along this fiber optic cable in the form of light. Now coming to each physical media in detail, first we have the twisted pair. You can see that we have two different wires twisted together, right? So usually in this twisted pair, it consists of two different conductors. Normally copper conductors will be there. Each conductor will be separately insulated by plastic, and these two wires are twisted together like this. And why we are using these two different wires and why we are twisting these together, we will see. A twisted pair consists of two conductors, each with its own plastic insulation twisted together. One of the wire is used to carry signal to the receiver, and the other one is actually used as a ground reference. One will carry the actual information, the data we will convert into signal, electric current here, right? Yeah, the actual data will be passed over one wire, and the second wire will be acting as a ground reference. So at the receiver, it uses the difference between these two as the information. And why we are using this twisting, that's a question. We will see the answer here. Of course, in addition to the signal carried by the sender on one of the wire, interference and crosstalk, some noise, extra signals will be added on the way, right? And this noise may affect both wires and create some unwanted signal that is received by the receiver. Of course, that is the case. On the way, some extra noise or some extra unwanted signal will be added over. So if you are using these two wires in parallel mode, what will be the problem we will see? If the two wires are parallel, the effect of these unwanted signal is not the same in both wires, right? Because they are at different locations relative to the noise or crosstalk sources. This results in a difference at the receiver. Just for example, if we are keeping these two wires as parallel wires, so the noise always will be, the source of noise also always will be closer to one of the wire and further to the second wire, right? So the wire which is closer to the signal, noise signal or noise source will be more affected. So of course at the receiver, when we take the difference, that effect of signal or noise signal also will be there in the receiver. So the receiver, the signal received will not be the same as the one sent by the sender. But if we are twisting these together, a balance can be maintained. How? That we will see. For example, suppose in one twist, the wire is closer to the noise source and the other is, one wire is closer to the noise source and the other is further, right? In one twist. And in the second twist, the reverse will happen. The second wire will be closer to the noise source and first one will be further from it. Like that in alternative twist, the distance will change, right? And in effect at the receiver, when we take the difference between these two wires signal, almost the effect of noise will be cancelled out. We will receive a signal almost same as that sent by the sender because of this twisting. That is the benefit of twisted pair. So twisting makes it probable that both wires are equally affected by external influences like noise or crosstalk. And this means that which calculate the difference between the two at the receiver, it receives no unwanted signal. And coming to this type of twisted pair cable, we have two different categories: unshielded twisted pair cable and shielded twisted pair cable. In case of commonly we are using this UTP, that is unshielded twisted pair cable, and IBM has introduced a new type of shielded pair that is called shielded twisted pair, STP. But actually that is used only there in IBM. Most commonly we are using this UTP. And what is the benefit of STP? Because STP has a metal foil or braided mesh covering that encases each pair of insulated conductor. So over the two insulated conductor, again extra protection is provided using a braided mesh. And this metal casing surely improve the quality of the cable by preventing the penetration of noise and crosstalks. So quality of the signal will be improved because of this extra protection, but it makes it more bulkier and more expensive. So we are not using much commonly. So we can see that this is the unshielded twisted pair, and here an extra protection is provided using a metal shield. This is the shielded twisted pair. Now we have different categories of twisted pair cables depending on the cable thickness and all. We have different categories. Category 1 is actually unshielded twisted pair used in telephone lines. Here the data rate is very low, it is less than 0.1 megabit per second, and it is a commonly used one in telephone lines. You remember earlier time when we used the internet over the telephone lines, it was very slow, right? That time we were using this unshielded twisted pair cable, and some more improved one is unshielded twisted pair originally used in T lines. T line is actually high data rate telephone line, transmission lines that time. So there we are using this category 2 UTP cable, and up to 2 megabit per second was the speed at that time. And again improvement over this category 2 is category 2 cable, which is up to 10 megabit per second, which is used in LANs, and we have category 4 and 5, and those are also used in LANs with a data rate of 20 megabit per second and 100 megabit per second. And how we can connect our device using this UTP cable? We should have a port like this in the device, and we have the connector pin at the end of the cable like this. This is RJ45 female port, and this is RJ45 male pin connector. Using these two connectors, we can connect our device to this UTP cable. And what are the different applications of UTP? Of course, used in telephone lines, right? Twisted pair cables are used in telephone lines to provide voice and data channels. And in case of local loop, that is the line which connects a subscriber home, a telephone subscriber, to a corresponding central telephone office. To that also we are using this UTP cables. Next type of guided media, that is coaxial cable. Coaxial cable is actually carries signals of high frequency ranges. So more bandwidth can be occupied in coaxial cable than those in twisted pair cable. And because of main thing is that it is constructed quite differently. We will see how the cable is constructed in case of coaxial cable. So here, instead of having two different wires, coax has a central core. It's usually a copper wire, either a single central core conductor or of solid, or stranded wires will be there. And this central core is actually enclosed in an insulating sheath, which in turn encased in an outer conductor or metal foil or a braid or a combination of these two. And the outer metallic wrapping serves as both a shield against noise and the second conductor, and this outer conductor actually completes the circuit. This is how it is actually constructed. We will see the figure. And this outer conductor is also enclosed in an insulating sheath, and the whole cable is protected by a plastic cover. So this much extra coverings are there for this coaxial cable. So this is how it is actually constructed. We have the inner conductor here, and that is protected using an insulator. Again, outer conductor is there, a metallic braid, and then insulator, again a plastic cover protecting the entire coaxial cable. This is how it is constructed, and that is why it is having the capability of accommodating a high bandwidth. And coming to different types of this coaxial cable standards, we have radio government ratings, okay, and that is called RG. Each RG number actually denotes a unique set of physical specification, including wire gauge, the measurement of the wire of the inner conductor, the thickness and type of the inner insulator, the construction of the shield, the size and type of the outer casing. Everything will be reflected using this RG number, radio government rating number. So RG59, the impedance is 75 ohm, and it is mainly used in cable TV. And RG58 is used in thin Ethernet, and RG11 is used in thick Ethernet. So these are the applications for this different coaxial cables, and how we can connect this coaxial cable to our devices. And we have of course a set of connectors for this. And to connect the coaxial cable to device, we need coaxial connectors. The most common type of connector we are using is BNC connector, bayonet nail concealment connector. This is how it looks like. There are three components for BNC connectors. One is called BNC connector, second one BNC T connector, and the third one is BNC terminator. And BNC connector is usually used to connect the end of the cable. You can see at the end of the cable we should have this BNC connector, and this can be used to connect to some device like TV set, etc. For that we are using this BNC connector, and BNC T connector usually used in case of Ethernet network, okay, LANs and all, and that is mainly used for branching out to a connection to a computer or other device. So if we have to connect two or more devices, in that case we can use this BNT connector, and the terminator we have this one, right, and that is used to connect the end of the cable. At the end of the other end of the cable we can have this BNC terminator, and which is mainly used for preventing reflection of the signal if we keep open the cable. Okay, so just to close the end of the cable we are using this BNC terminator. If we check the performance of coaxial cable, as we know it can accommodate more bandwidth, right? So of course the speed of the data or data rate will be more in case of coaxial cable compared to twisted pair. But at the same time there is a drawback that attenuation is much more higher in coaxial cable than in twisted pair. In other words, coaxial cable has much higher bandwidth, but the signal weakens rapidly and require frequent use of repeaters. So over the cable in between we have to place some repeater to improve the quality of the signal. That is coaxial cable. And coming to the application, coaxial cable was widely used in analog telephone network, earlier telephone networks, where a single coaxial cable could carry 10,000 different voice signals. That was the main advantage of this coaxial cable. And later it was used in digital telephone network also, and up to 600 megabit per second data rate was achieved using this coaxial cable, and it is used in telephone network, and later it was replaced by this fiber optic cable. Cable TV network also earlier it was used, and currently most of these cables are replaced by fiber optic cable. That's all about coaxial cable.